Okay, hyperbolas. One thing you're going to notice about hyperbolas as we get into this is that a lot of the equations you learn about ellipses are going to be very similar. Okay? There are a lot of similarities, but there's also several new things that we're going to have to learn about. And one of the things I need to do is give you some graph paper. So I'll pass out some graph paper right now. Do some graphs. And I'm going to do a couple examples in my lesson that I would do on your study guide somewhere. So,
can I do it on a different piece of paper? Or
you can do it on a different piece of paper, but hyperbolas, there's quite a few more steps involved than ellipses. Ellipses are pretty easy. Hyperbolas have several more things to deal with. Welcome. Okay, so here's some graph paper. So that way, when you get, you're welcome. Very welcome. Okay, so graph and write equations of hyperbolas. All right. So I didn't do anything cool this time. Shh. George, come on, wake up. Students will be able to graph and write equations of hyperbolas. What kind of figure can be used to locate the vertices? That's actually a very important tool. We're going to see this in just a few moments. It turns out that's a rectangle. So, this was normally what we do for some warm-ups, but I'm going to skip over that because those are ellipses and we already know how to do that. So now if you have your book open, please open up to page 518 because I didn't make a photocopy of this page because your book already has it, and I'm just going to... Not for this one because it comes out blurry anyway. So I end the show and I'm going to show you that page on my computer. So those of you that don't have your book, I can show you what the page looks like. Oh, come on. Don't do that. Okay, try this again. Okay, we'll try this through Internet Explorer instead. Alright. I'm trying to go to my web page. Oh, you're kidding. No, I can draw it myself. Okay, guys, take a look. What you're going to notice is that there's a couple equations for hyperbolas.
X squared minus y squared equal to 1.
This is the first conic section that we've been looking at that actually has a minus involved. Well, sort of. I mean, parabolas could have negatives involved too, but y squared equal to 1. And you should have another equation that's written this way instead. Y squared over a squared minus x squared over b squared is equal to 1. Now, some things you should realize about ellipses that are different, about hyperbolas that are different from ellipses. You remember the a squared was always the bigger? Like when we were doing ellipses, if you had x squared over a squared, then we knew something about the ellipse. We knew that it was elongated in the x direction, right? Well, that turns out not to be the case with ellipse hyperbolas. Again, that turns out not to be the case. So, in fact, a squared could be the smaller between a squared and b squared. The bigger one is not necessarily the a squared. The bigger one is not necessarily b squared either. So that's one thing to realize about hyperbolas. Now, when you look at the graph in your book, you probably have a rectangle drawn like this in the middle, and then you probably have these lines that go through the diagonals. And you have a line that goes through this diagonal like that. Imagine those lines are straight. Now I need you to use your imagination because it's hard for me to draw using this this pad thingy that's supposed to go through the center here. Now you probably see a couple branches drawn with a vertex right here and a vertex right here that's drawn this way, and it goes towards this thingy, this line here. This line here is what we call an asymptote. Now in Algebra 2 we haven't really talked about asymptotes that much yet. It's asym. Okay, asym, and then there's a P in there, and then there's a tote. Okay, and we say it asymptote, right? But the P is really hard to get in there, right? Asymptote, right? Asymptote. Asymptote. So the P is kind of silent. Just try to pronounce it without the P. Asymptote. Okay, so the way the asymptote works is that the branch never actually equals the value at the asymptote, but it gets really close. Really close to the asymptote. But the function, the graph itself, never gets there. And it gets really close, like almost right smack on top of it. And that's how asymptotes work. You never actually get to the asymptote. You get really darn close. Well, that one I sort of drew. And so you probably noticed this. Now, the hyperbola are called like branches. These are the branches of the hyperbola. There's two branches. Now, you might wonder, why aren't there branches over here in the y direction? Going this way towards the asymptote also. Why aren't there branches? Now imagine these look like this. Oh, by the way, these look like parabolas too, right? I'm going to talk to you briefly here about what the differences are. First of all, hyperbolas also always have an asymptote that they approach. As you graph them, they approach an asymptote. Parabolas don't. Parabolas go on and on and on. They do not have asymptotes. They go on up. They go on this direction forever, and they go upward, whatever. And so this is one way that parabolas are different from hyperbolas. But like parabolas, they also have a focus point. And the focus point is always going to be on the inside of that branch, like kind of sitting over here. So this might be our focus point, and this might be our focus point. So yes, that's how we derive the equation. So, but getting back to this question, why is there no branch under the y? Okay, that's a fascinating question. Would you like to know the answer? Why? I mean, you could say, well, why aren't there four branches and why aren't there 4 focus points? Looks like there could be. So you're going to notice something. If you're looking at the equation with x squared, the one that's positive is where you have the branches. The one that's negative, you don't have branches. Now, what is it about negative? It's like, come on. What did negative do so bad that warrants us not to graph on the negative? I don't know. Well, I'm going to share that with you. I'm going to share with you why there's no branch here on the negative. You notice on this one, if you look at the graph on your book, it does have a graph in the y direction. The branches are in the y direction, right? Let me erase this mess. And you'll notice the graph on this one. It also has a box in here like this, a rectangle. And this time you have diagonals that go like this. You have another diagonal going through like this. This actually goes through the origin, so imagine that goes to the origin. And this time the branches go this way, right? And remember, the graph has to go towards that asymptote. The diagonals are the asymptotes. And so you never have another branch that goes this way, right? Mm-hmm. Well, so in this case, then, why aren't there branches over here? Okay? Why aren't there just 4 branches? It would actually look kind of cool if there were 4 branches. But again, the branches only occur on the positive variable, where you have the positive y squared over a squared. The negative one does not appear. So let me go into why that happens, because I know you're just dying to know. Well, maybe not dying, but you could hardly withhold the excitement of this secret, right? Fascinating, yes. So let's just imagine something for a moment. Let's just imagine for a moment that x is equal to 0. What would happen to this?
X squared 0 over every straight line, no?
0 over a squared is 0. So this whole thing would become a fat 0, right? So if x is equal to 0, then this whole part here disappears and it's gone.
So
now let's take a look at what's left here. And what I want to do is multiply through by -1. And so that changes this one to y squared over b squared is equal to -1. Now if you look at this carefully, it's absurd, right? What do we know about squared numbers? Are they ever negative? No, negative times negative is a positive. So I have a positive number divided by a positive number equal to a negative number. That can only happen if what?
we have an I in it.
If we have an I involved. Look what happens if we multiply by b squared. Multiply by b squared. We'd have y squared is equal to -1 times b squared, right? And then if we took the square root here and the square root here, what do we have? The square root of -1, which is I. And the square root of b? B. So you'd have y is equal to plus or minus IB. Are you starting to understand why there is no branch on the y-axis?
Yeah.
It's because it's a complex number at that point. And so we don't, when we're graphing the real number solution. And so back up here, when I was showing you the graphs, there's nothing on the y-axis then. And so it's the -1 that has the complex number solutions. Does that sort of make sense? So there will be no graph in the y direction because it actually leads to a complex solution. Okay, so the only graphs are going to be on the positive one. Now, there's a couple other things that come up. On your table, or on your page 519 or whatever it is, isn't there an equation down at the bottom that tells you how to find the focus points? C squared is equal to a squared plus b squared this time. Now, it's sort of like the Pythagorean theorem. This is for right triangles, but this turns out that we're trying to find the focus point, and it involves a right triangle. But I can go into that some other time. But the point is, how does it compare? How does it compare with ellipses? Yeah, see, when we had ellipses, it was a squared minus b squared. Remember that? And that's why the a squared term had to be bigger. It's because you're subtracting. And we don't want to have imaginary numbers. So we made the a squared always bigger in that case. So this is the case with ellipses, right? Ellipses, okay? But this is the case with hyperbolas, okay? So that's another thing to notice. Now, you'll notice that hyperbolas also have these asymptotes in it. So I'm going to show you how you can find those asymptotes real easy. Turns out there's a real easy box that we can draw in there. So I think I'm ready to go back to my PowerPoint. And I'm going to work out some examples. Now, we're going to do at least a couple examples, and I'm going to work through them really slow because they take a while. But by the time we do 70 of them, you'll be getting really good at them. Okay, well actually we're going to do 2 of them together, and then you're going to do several of them on your study guide. Okay, let me start off with this example right here. I know, but hold up. This one's easier to do. Yeah, is this in standard form? No, it isn't. So, our first job is to get it into the standard form. There's no 1 over here. We divide through by 100. And divide this one by 100. Divide this one by 100.
Yeah, y
And as a
squared,
result, we get,
y
how many times does 25 go into 100?
4.
We get y squared over 4 then. And then we get, whoops, not a plus. Back that off. We get x squared. How many times does 4 go into 100? 25. So we have 25 here. And then we have a 1. Now we have things in standard form. So that's the first step. Write it in standard form. The second step is always going to be to make the box or make the rectangle. Make the box. Okay, so here's how the box works. It works just like the ellipses. You know, if this is a squared, what's a?
2.
Plus or minus 2, right? If that's your a squared, then a is equal to plus or minus 2. So in the y direction, I'm going to use this cool pink color, purple pink. There's a plus or minus 2. Now if you're graphing ellipses, these would be the vertices, right? Well, what about this case here? If that's my b squared, then b is equal to what? Plus or minus 5, right? So that means we put a 5 right here and a 5 right here. Now, if we were drawing ellipses, we would just put a little oval thing in here, right? Okay, but instead of drawing an ellipse in here, we're going to be drawing a rectangle. I'm going to back that off. So the way you draw your square, well, you just kind of go up and down on this one, up and down this one, go horizontal with this one until they intersect. And so they go right to here, go to here, and then go over this way and this way. Now your guys' hopefully will look more straight than mine. And so I'm trying to draw this freehand on a pad, so it's a little bit harder for me. So there's your box. So does that make sense? We did this step right here. We made a box.
Honestly, I can't see that purple.
You can't? Okay, I'll switch colors. Let's do this cool green color. You can't see it. This looks really cool, actually. I'll use this hideous green. Okay, so now what I need to do, and I'm going to try to do this, I need to draw an asymptote that goes through this corner, and it needs to go through the other corner. That's pretty close. Okay, that's pretty close. All right. Isn't that cool or what? That's pretty straight. All right. So there's one of my asymptotes. Okay. And now I'll try to draw on the other one. The other one goes what?
So does it have to go through the origin?
It's supposed to go. Okay, it went through the origin.
The what?
The asymptote goes through the origin. And the diagonal should always go through the origin. Okay, so let me see if I can get this one. Yeah, I'm going to slide it down a little bit more. There we go. Alright. This is hard to do. I'm trying to use a straight edge to get me a straight line. Oh, what the hell? Oh, hold up now. Don't even... Oh. What? Oh, you're kidding me. That's not funny. You guys aren't supposed to laugh. What happened to it? Oh, wait. Oh, where's my other page? Oh, no. You're kidding me. I have to redo this whole dumb thing?
That's okay.
Oh.
Just redo it again.
And just redo it again. Okay, so we had a 2 here, right? Okay, I'm going to do this. Make my pen... I gotta make my line sticker. Gotta go back to that. Okay, so there's 2. What are you guys laughing? You guys aren't supposed to laugh at me. Okay. Yeah, you guys shouldn't be mean.
No, they're laughing at me.
Okay, so there's... Ah. Alright, so... This is annoying. Okay, so alright. It goes to the origin. There you go. Look at that. Man, this is actually kind of hard, so alright, I'll go back to my blue. You guys are attacking my colors now.
No, that's too dark.
Okay, so now remember what we had? We had y squared over 4, and we had minus x squared over 25. And we had this is equal to 1. Now remember, at the very onset, you could have like 4 branches, but there's only going to be 2 of them. Now we know from this information right here, the branches have to be on the y-axis. Now, these brown lines are my asymptotes.
Those are orange.
They're orange?
Yeah.
Okay, so that means as I go this way, I start to curve upwards, I go towards the asymptote like that. And as I go this way, kind of go towards my asymptote like that. It kind of looks kind of like a parabola, but unlike parabolas, hyperbolas go towards asymptotes.
So which you gotta be close to?
Yeah, it's going to get really, really close.
We can make an estimate of it then?
What? No, you can just kind of graph it like I did. You don't have to plot any points or anything. Just, okay. But, if you drew the branches over here, now it's wrong. It has to be what we call the transverse axis. The axis that has the real solutions, it's called the transverse. Transverse
Also, you
axis.
can't use dark on dark.
Yes, I can. I can see it just fine.
Well,
because
you
you're in
can,
front of
but you
it.
can.
Wine.
In a little bit.
Transverse.
George, shut up! Oh my God.
Okay.
Oh,
Now, this axis is called the imaginary axis. I wonder why. The imaginary axis. Okay. Yes, it has imaginary solutions. So that's why there's no branches over here. Because we're graphing only in the real number system.
So we
Okay.
use y2.
So we almost have everything done, but where are the focus points?
I don't know. A squared plus b squared.
Yeah, remember the new equation now? It says c squared is equal to
Russell, I got a
8.
question.
Yeah,
Okay, so the parabola goes through the point.
hyperbola.
Is that what I said?
no,
You said parabola.
Hyper.
Goes
Oh,
where?
It goes through the tube.
Yeah, that's why I drew it there. That's where the vertex would be. Okay, now keep in mind the focus point has to be on this axis also. Does that make sense? Okay, so let's take a look. C is equal to then, in this case we had 4 plus 25. That makes sense? Which equals 29. So c squared is equal to 29. We take the square root here, I get c is equal to plus or minus, it's about 5.3 I think. Square root of 29. I'll do that on my calculator for you. It's 5.38. So 5.38. So we're just going to say it's about 5.4, okay?
okay.
So the focus point is, I'm going to use my cool black color now. 5.4. There's focus number 1. 5.4 is right about there. There's my second focus. Now that actually looks pretty cool. I mean, I use all sorts of good
So that's
colors.
the fucky?
It's not, it's foci. Don't give me those F words that are inappropriate in math heaven. You're going to be hit by lightning on the way out.
Uncle, don't say that. That's scary.
Well, that's why we shouldn't be blasphemous in my math class.
Scary, that's scary.
You don't
No.
Why? I did it last night.
It's my chocolate. I pay good money for my chocolate. I'm
You
a
know
chocolate.
what? Tomorrow I'm gonna bring all of my chocolate and I'm not.
So Russell,
But you can't eat it.
Russell,
What?
those little butts are your focus?
What? Yeah, foci.
The foci for this doesn't have to be inside the rectangle.
It has to be the hyperbola branches open up around it just like parabolas. Okay, so you know it's not going to be over here.
So tired.
Now take a look. We need to do this part of the problem though. Okay, so let me address those concerns. Yeah. I haven't show your mom and dad.
Russell, go on.
I'm trying. Okay, you guys ready? What are the vertices? You guys see this? Vertices.
You're so funny.
I know, I crack myself up. Vertices. How about if we write those our shortcut way? 0 plus or minus 2. Make sense? How about our foci?
Foci is
How about 0 again? And plus or minus square root 29. Remember that's what it was, right? How about the equations now of those two asymptotes? And it's not asymptote. Asymptotes.
oh my god.
I see him.
Asymptotes. Leave the P out. You're probably okay leaving the P out. Unless you can try to say it. Asymptotes. Okay. So, it's y equals. Now, let me show you a real easy way. Now, you can use your cheat sheet at first, but it's actually real easy to get the equations of those asymptotes. Remember what the equations of lines are? It's like mx plus b, right?
Mx plus b.
Now, the nice thing about the b is that it passes through the origin. So there is no b because it's 0. All you need is the slope, which is the rise over the run.
I'm looking over there.
And if you look at this box, you have the rise over the run. And you go over this way, how far? And this way. The run is 2. The rise is 2. The run is 5. So, if you want to write this as the equation, you'd write it as 2 over 5 x. And to get them both, all you need is a plus or minus here, because that gives you the other one. You see? You have 2 asymptotes. So that's why you have a plus or minus in here. So do you see how we got those equations? We got the vertices, we got the foci, and now we have the asymptotes. We had the beautiful graph, and we did it. Now, your goal is to get that down under 4 minutes. Okay?
Go under 4 minutes.
Yeah, do the whole thing in 4 minutes or less. Alright, so I have enough time to try one more. So now let me try a little bit more challenging one. This one. Oh, I want to get the graph in there too, my graph paper. Okay, so once again, this is not in standard form. Now I want to show you a cool little algebra trick here that you may have to use from time to time. It's an algebraic trick here. So this is a good example. But we're going to divide by 9 here, right? Divide this one by 9 and divide this one by 9. Right? And so that's going to give us x squared over 9. Now I want to show you a cool little trick. I'm going to write this as y squared. Now, to get it in standard form, I want the coefficients on the x squared and y to be 1s. And there's this flippant 4 right there. So, I want to show you a cool algebraic trick. You can write this as 9 divided by 4. Like that. It's not up there anymore. Now, I'm going to show you this once. Why does that trick work?
Because you're dividing it twice. Babe, why do you want to divide one
I got that 4 and I put it down here. But why does that work? Well, let's take a look and see what happened here. I'm going to do it in slow motion here. If you have this scenario, I'm going to show that this is equivalent to what we started out with right here. This symbol here means divide, right? Well, then what we really have then is y squared divided by 9/4. Now we learned way back in 4th grade that we can change to multiplication by flipping the fraction on the right. So this becomes y squared times 4 over 9. And if you do that, you get 4y squared over 9, which is what we started out with. Remember? That's what we had right here. So a nice clever way to, you just put that 4 down here in the denominator and you've gotten rid of that 4. Does that make sense? You want to do that. Okay, so now after we've done that little cool trick, and hopefully I'm not going to show you anymore, hopefully you'll just memorize that little trick, because you'll have to use it from time to time, maybe even on a test someday. Now we proceed and graph like we did the previous problem. If this is my a squared, then what's a? Plus or minus 3. So in the x direction, you come over here and put your vertices in. Alright? Now, if this is b squared, what's b? A little bit trickier, right? It's not too tricky though. If b squared, you can take the square root of 9 and write it over the square root of 4, right? But what is the square root of 9? It's 3. What's the square root of 4? 2. So b would be equal to 3 halves, right? Which is equal to 1.5. So it turned out to be not that bad, right? So in the y direction, you go up 1.5 and put a little dot, one right there. Now, so step number 1 was coming up with the standard form, right? That was step number 1. Number 2 is to draw the rectangle. Okay, so once again, you just kind of try and do this. Drawing that rectangle, kind of go down this way, 1.5, go this way. Kind of go up this way, 1.5, kind of go over this way. And draw in your rectangle. Now the reason why we want that rectangle is so we can get those asymptotes in there. Now I'm going to use my cool color now. What's my cool color?
Turquoise.
Turquoise, this one?
Yeah.
Alright, we'll try that. So I'm going to try and draw my turquoise diagonal in here. This is actually my asymptote. Now some people like to put that in a dashed line. I'm totally okay with that. If you want to make that a dashed line, go for it. So there's my asymptote. Okay. Now again, where are the branches? Hyperbolas always have 2 branches, and 2 of them are like gone. So where are they going to be? It's always going to be under the positive or the transverse axis. So in this case, the hyperbolas are over here, right? There's a branch that goes over this way and goes towards that asymptote, and there's a branch that goes this way. Now, in some ways, the hyperbolas look like parabolas. I agree. The difference is that these actually approach an asymptote, and they will never cross. Okay? And so, parabolas, on the other hand, would keep on going. Okay, the last thing we need to do is figure out where these focus points are. So remember, we have c squared is equal to a squared plus b squared this time. And so now what we need to do is do this. 9 plus 9/4, right? Now, those of you that suck at doing fractions better use the calculator on this maybe. But I would say write that as a fraction and multiply by 4 here, multiply by 4 up here. And that gives us c squared is equal to, what's that, 36 plus 9, which is 45 over 4. And then we take the square root here, square root here. Huh? Take square root.
4 times 9 is 36, plus another 9.
Which gives you 45.
Oh, never mind.
And so then we get square root of 45. Well, what's the square root of 4? 2. And that doesn't do us a whole lot of good, does it? we're going to plug that into our calculator and find the approximate answer. So my friends, I will do that for you. Square root of 45 divided by 4 is 3.35. Basically 3.354. So we're going to just say it's approximately 3.4. Which
I thought we were dividing it by 2, not by 4.
I did divide by 4.
It's by 2.
Inside of here, it's 4. And then I took the square root.
Oh, okay, got it.
Yeah, so I did it right. Well, where's that put my focus point? It's just barely off the vertex, isn't it? My focus point is barely 3.4. It's sitting right next to the vertex. So there's F1, there's F2. Now, by the way, can you list the vertices, the axis, or the focus points now and all that jazz? Do I have enough time? Yeah, I have enough time. Let's do that. What you're going to have to do, what the hey, don't tell me. Don't, oh, that scared me for a second. Move this dumb thing out of the way. Okay, so let's make a list of all our calculations we were supposed to do now. We need, I'm going to use a different color now. I need the vertices. Is that easy? Okay, the vertices. It's on the x-axis now, so it's plus or minus what? 3, comma, 0. How about the foci now? The foci, it's on the same axis, and it's just barely next to it. We could write this as plus or minus square root 45 divided by 2, comma, 0. Everybody good with that? Or if you want to use the decimal, that's fine. How about the asymptotes? The asymptotes, alright, now this one's a little bit tricky. Now remember what we had. We want the equation of those blue lines. And so it's going to be y is equal to plus or minus. Remember what you need here? You need the slope. Well, what is the slope? The rise part was 1.5. The run part was 3. Now, actually, I'm okay with you writing it like that. Now, if you write it in fraction form will look a little bit different. So let me show you the calculation for that. If you want to write it in fraction form, here's what we'd have to do if we want fraction form. We'd have to write that as 3/2 over 3x. Okay, and we have plus or minus, right?
No.
But that's actually equal to 3 over 6 plus or minus x. And that's equal to plus or minus 1/2 x. So you see what I did? So you'd have y is equal to plus or minus 1/2. Okay, and you can see that's right, because what if we went over one more time? We would go over to 6 and we go up to here. What's the rise over run now? It's up exactly 3. The run is 6. See, so the slope is 3/6 or 1/2. Make sense? Okay, so now I would say that's also equal to 1/2 x plus or minus. Wow, wasn't that fun?
Hey,
So-
Russell, I got a question.
Yeah.
So if you had y squared over 16 under 4 over 4, can you just put 4 for that?
Yeah, of course. Yeah, that's how you would do it. Okay, so we did a couple examples. I think this is a good stopping point